Hello, and welcome to this Vivado Quick Take tutorial focusing on migrating UltraScale memory IP into the 2015.1 Vivado Design Suite. It is important to note that this process is only needed when migrating to the 2015.1 release, and it is not expected to be needed for future releases. The agenda is going to start off by reviewing some of the I/O planning methodology changes that were made to the memory IP in the 2015.1 Vivado Design Suite. For more information about these changes, you can refer to the Designing with UltraScale Memory IP Quick Take tutorial, or in the Vivado Design Suite I/O and Clock Planning User Guide. We'll then migrate a 2014.4 design that includes two memory IP into the 2015.1 release. We'll review the MIG-IP update log for the migration instructions for the I/Os. We'll then apply the scoped I/O constraints from the MIG-IP to the migrated design. We'll then apply the constraints for the system reset port since the I/O clock buffer has been removed in the 2015.1 IP. We'll then run the design rule checks for the memory IP I/Os. And finally, we'll save those constraints, those scoped I/O constraints for the MIG-IP itself, to the top-level design, which will inherit all of the top-level port names. We'll then implement the design with these new top-level I/O constraints, and we'll examine the physical layer implementation during the app design step. We'll then open up the implemented design and look at the floor plan constraints that were created during the app design step. So as a recap, the 2015.1 UltraScale memory controller IP does have the simplified memory customization that includes a drop-down to select the type of memory you'd like to implement. There's a button underneath this pull-down to enable PHY implementation only. And most importantly to this presentation, we've centralized the I/O planning task for memory IP with the I/Os for the rest of the design. It's now consistent behavior with all the other IP in the catalog. And the advantage that brings you is it does allow you to change your I/Os or even target a different device without recustomizing the IP. And it also allows you to do centralized pin planning when you have multiple controllers in your design. So I'll start by opening up the 2014.4 version of Vivado. And here you can see I've got my example design targeting an Akintex 060 device. This design has two memory controllers, a DDR3 and a DDR4. And if you remember in 2014.4, all of the I/O constraints were stored within the constraint file in the IP itself. And you can see here I've got package pins and I/O standards and so forth for this particular IP. And also, if you remember in 2014.4, as it's with all previous releases of MIG, all of the I/O constraints are specified during I/O customization itself. And here you can see you've got the bank planner and the pin planning capabilities within the IP customization wizard. And there was even a graphical pin planning environment specific for MIG that I could do manual adjustments to the pins. So in 2014.4, I've taken this design through synthesis and implementation. And if I open up the implemented design, I can see my two memory controllers floor planned with their P blocks inside the device view. Notice down below here in the timing summary, I can see that these both have met timing and are good to go. Now let's go ahead and open this design in 2015.1. And notice the first thing it asked me if I wanted to upgrade the project to the current version. You should always make a backup copy of your 2014.4 projects before migrating them forward. Once the project is upgraded, it recognizes that I have 2014.4 IP in my project and asks me to automatically run the report IP status command. When I do that, you can see that I've got both my memory controllers are due for an upgrade. I'll elect to do that. It walks me through the upgrade progress and regenerates the IP. Notice I do get critical messages telling me that I do have port name changes in this IP and to review the upgrade log for more information. I'll elect to generate the output products using out-of-context synthesis for the IP. And notice here the synthesis runs have started and the output products have generated. Notice new in 2015.1 as well, I can look at the different report logs for each of the individual IP as they're running. So now after synthesis is completed on the out-of-context IP runs, let's go ahead and look at the update log. The update log can be viewed in two locations. Firstly, if I rerun the report IP status here, I can see the upgrade log's been refreshed, and it has the information about the various ports and changes that were made to the IP in this release. An easier way to look at it is up in the sources view. Notice I've also got the upgrade logs here. In detail here, this first warning tells me that there was an XTC file that was created that contains the I/O constraints for the IP. These are the scoped XTC constraints that we'll be reading into the 2015.1 release to migrate the IP I/O constraints into 2015.1 top-level constraint files. Notice there's another message about the sys reset pin. In 2015.1, the I/O buffer that was inside of the IP for the sys reset port has been removed. This will enable you to more easily share the resets amongst different IP or other resets in the design. And here you can see explicit directions on how to reset those I/O constraints that were applied in 2014.4 in your 2015.1 design. And we'll go through that. And notice the same messages are in the update log for the DDR4 as well. And notice now when I open up the constraints file that's down inside of the IP, it contains no package pins constraints. It does have I/O standards and output impedances to help get you started when you're doing your pin planning, but there are no I/O ports physically assigned. So that's the IP upgrade process. Now let's move on to pin planning. So starting in this release, you can now do your pin planning for your MIG I/O within the elaborated design. So this is pre-synthesis. I'm going to open up the elaborated design, and you can see I selected to load the I/O planning view layout to provide the views I need for doing I/O pin planning. And if I look down in the I/O ports view, I can see that all of the ports associated with each one of the memory controllers have been grouped into an I/O port interface. Notice that none of the pins are placed for either one of the memory controllers. That's because the I/Os that were scoped within the IP itself now need to be migrated into this design into the top-level constraint files. Notice the 3 ports here that are placed. Those were the top-level status ports that were placed in the top level of my example design, so they're still placed here because they are still top-level constraints. Now let's go ahead and read in the scoped XTC constraints for the memory I/Os into the elaborated design. We do that by using the read XTC command with the -cell option, and I give it the instance name of the DDR3 controller in this case, and then the file that was shown in the update log for the IP. Now that file is going to be wherever your IP was located in your project in 2014.4, and in this case it's down inside the project sources directory under the IP subdirectories. And when that command is run, all of the ports are now displayed for the DDR3 controller. I'm going to go ahead and do the same thing for the DDR4 to import those I/O ports. And here you can see the DDR4 controller ports that are placed. Now we need to address the sys reset pins. And to do that, I'm going to bring back the update logs that tell me the specific ports and I/O standards for each one of those resets that need to be applied. To do that, I'll go to the I/O ports view and adjust those fields manually for the site and I/O standard fields. Now before saving any I/O related constraint modifications, you should always run the drc command to ensure that you've got no I/O related issues. And here you can see the only warning I've got is that I don't have my configuration voltage set, and I could easily do that in the edit device settings dialog. There are no memory I/O related issues, so let's move on. The next step, which is critical, is the save constraints command. This will actually propagate the MIG I/O port names up to the top level port names and save them in the XTC file. And if I look at the constraint set that I'm going to apply to the run, I can see that there have been 2 module level XTC files that have been added, which are a result of us running the read XTC command. If I double click on these files, I can see that all of the I/O constraints for the IP has successfully been migrated to top level constraints. And you can see the same thing for the DDR4. Now, if you prefer not to have extra XTC files added to your constraint sets, there is a method you can use to actually propagate all of these I/O constraints into the single top-level constraint file. To quickly demonstrate that, I'll first remove these two XTC files from the project. So we're back to square one. If I go back to the elaborated design and run the read xtc-cell commands with the -no add option, all of the constraints are read into memory. And then when I do the save constraints command, they're read into the target XTC file, which in this case can be the top level XTC file you've got here. You may need to select the file that you want to write the constraints to and right click to set the file as the target XTC file to write new constraints to. So that's your option. You can manage your IP I/O constraints in individual constraint files, or you can manage them all in a single file. And these are top level files that you can edit manually. You can clip and paste and manage these constraints as you see fit. So now we're ready to re-implement the design. When I click Implement Design, it asks me if I want to rerun synthesis because my constraints have been modified. I'll say yes, but I don't have to. I'll let it synthesize. And then when it starts implementation, notice the first step in the OpDesign command is called Generate and Synthesize Make Cores. This is where the physical layer, or PHY, is being implemented and stitched into the netlist prior to implementation. And you'll see it run here for each of the cores in my design. Once the design has been implemented, I'll open the implemented design. And notice that you'll see the P blocks that are generated in 2015.1 are different than those we saw in 2014.4. Firstly, the DDR3 controller doesn't have a P block at all. That's a new feature in that any memory controller that only occupies one I/O bank no longer requires a P block. Notice the DDR4 P block is very condensed. Rather than use multiple clock regions, we've condensed it down to try to use the minimal area that the memory controller will need to try to improve performance. And notice that both of the memory controllers in standalone mode here both meet timing. So that's it. That's the entire process for migrating 2014.4 memory IP into the 2015.1 release.